Hey guys, good to see you again. Hope you guys have been enjoying the videos and stuff that I've been sending you, and here's another one. This one we'll be talking over the course of the next 3 weeks about the rock cycle, starting with the first kind of rocks, igneous rocks. Now, rocks are very special because when a geologist, that is, a person who studies the physical earth, explores rocks, they can tell a lot about what happened around those rocks by little clues that are on the rocks. What kind of rock it is, what happened in the area around it, even sometimes what kind of fossils can be found in that area simply because of the rock. In fact, it's thanks to this that scientists were able to figure out the whole meteor striking the planet and wiping out the dinosaurs thing. Sad face for dinosaurs. Anyways, so today we'll be simply talking about the first kind of rock. The rock cycle always starts from the same place. Now, according to that picture I sent you, it doesn't always have to end up in that place. It doesn't always have to go in a perfect circle. But the idea is that rocks come from deep below the earth. Molten rock, magma. When molten rock is underneath the earth, it's called magma. When it gets above the earth, it's called lava. Now eventually lava cools down. The kind of rock that comes out of that cooling lava depends on a variety of factors. How fast it cools down, what kind of stuff was in the magma, because magma isn't just one thing, it's actually a bunch of different chemicals and stuff. And that can very easily change what kind of rock we're dealing with. And there's so many different kinds of rocks out there that it's mind-boggling, honestly. Because you don't know, because rocks look so similar. And it's astounding because they can be made up of so much stuff, because there's so many different types of materials, atoms, chemicals that basically can form rocks. And it depends entirely on what happened when that magma was cooling. The main kinds that tend to form is when the magma cools very, very slowly. The rock actually has time to crystallize. Now, what does crystallize mean? Crystallize is when the atoms inside the rock actually form into shapes. The more complex and together that shape is, the stronger the rock. This is why some rocks are super strong. You could hit them with a truck and the truck will take more damage. Other rocks, super weak. It all depends on what kind of formation the atoms are in. And when they crystallize like that, they actually have the time to crystallize. This is what you can see different colors in the rock, different shapes in the rock. And sometimes you even see air bubbles, because those atoms have formed around those air bubbles. Sometimes those air bubbles leave massive gaps. Have you ever seen those rocks with those pores in them? That's a rock that has been given a lot of time to cool down. Now, what happens when it cools down slowly? It doesn't have time to form crystals. Instead, it might form little waves in it of color. It might have more of a shininess to it. This is what's known as volcanic glass. And one of the most famous examples of that is obsidian. Obsidian is a black rock, and it is formed when the magma has very little time to cool down, and it often forms when magma directly hits the water, so it cools down like this, instead of when stuff like granite is a famous igneous rock. Notice how granite has those different colors? Look at a granite countertop. I don't know if you have one or not, but maybe you have some relatives that can send you a picture of their granite countertop. If you don't have one, it has different colors in it. I'll include a picture too. But those but the reason is because the igneous rocks that were formed by slow cooling lava took their time to form the crystals, and they cooled in the air, as opposed to something like obsidian, which normally is created when it cools down, like, well, not like this, but very quickly. Sometimes when it hits the water, sometimes when the temperature outside is actually very cold. This is why you might find volcanic glass in areas where the volcanoes are very close to the water, or maybe somewhere like in Iceland, which is the air temperature is so cold that as soon as the magma hits the air, it starts to cool down. So that's how we get igneous rocks. Now, igneous rocks go through a series of chemical and physical processes. They can take on heat, they can take on pressure, they can break down, and they can turn into either sedimentary or metamorphic rocks, which we're going to talk about over the next couple of weeks. But the most important thing you need to know about igneous rocks is the fact that they are usually the first in the step. Igneous actually means fire, as in they are from the fire underneath the earth. And that's more of a crash course on igneous rocks right there. Obviously there's a lot more information that can be found, but to be honest, that would require, unfortunately, a lot more time. I wish I had more time to go over this in class and stuff, and it wasn't just making videos, because quite frankly, we really cut down on the time. But what I'm going to give you guys is a little worksheet linked to this video so you can learn about it. And I'm also going to give you a fun little website that you can look up along with a picture, and hopefully you have fun with it. Also, a little thing you guys can look up on the side, or maybe, who knows, we'll go over it after we go over the last type of rock, fossils. Because fossils are very important in the whole idea of how rocks form and stuff, because fossils are when organic bone matter is preserved and then slowly replaced. The organic matter that used to be connected to life is slowly replaced with rock. And that's a big process on of its own. Maybe we can do that afterwards. But right now, igneous rocks, there's your lesson on them. You got your worksheet. Hopefully you guys had fun with learning about this. Hopefully I didn't go too fast, because I was trying to compact a lot of information into this. Oh, yeah. And it's a mystery trying to figure out what kind of thing, what kind of rock it is, what happened during this rock's creation that made it what it was. And that's what geologists are trying to figure out. That's why they try to classify them as different things. That's why they try to give them names and try to see what it is. You can look up other kinds of igneous rocks, of course. Granite and obsidian are just two of the most famous examples. And that should be it for now. Next week I will post a video about sedimentary rocks. So look forward to that. And until next time, I love you 3000.